Okay, now we move to a new topic, double linked list. Previously, we have learned about singly linked list where the node have only one pointer. That means it points to the next node. That means the node will move forward. But for double linked list, it can move either forward or backward. That means we can see that the node has two pointers. The one pointer points forward and one pointer points backward. Okay, so having double linked list is very useful. Previously, this application can be done with traverse from beginning to the end, but this solution is not good because the programming process become complicated and runtime consuming. It depends on how long of the list. So when you have a singly linked list, it will become more complicated. It depends on how long the list is, and it's very time consuming if you want to traverse from the first node until the last node. Okay, so the solution is having a double linked list. It is more suitable and flexible method because you can move backward and forward. So each node can contain pointer to predecessor and successor, previous node and next node. So this is how it looks like, where you have a node with three variable. One is data of type integer, two pointer of type node, so previous point to the previous node and next point to the next node. Okay, right. So this is the structure of the node in C++, where you declare a node of type struct, and then you have two parts here: data part, data of type integer, that means data is a variable, and the link part where you have two pointers. One pointer previous point to the previous node, and next pointer points to the next node. So you need a pointer of type node because it points to a same structure of the node. Okay, that's why we call it a self-referential node. Okay, now let's say we want to insert item in double linked list. The item is 44 after item 35. Okay, let's say we have this current list. We have 21 first node. How do you know this is the first node? You can check the previous link. If the previous link points to null, that means this is the first node. Okay, and then 21 points to 35, 35 points to 54, and 54 points to null. That means this will be the last node. And of course, the previous of 54 is 35. The previous for 35 is 21. The previous 21 is null. Okay, then you have a current pointer point to 35, and the number of items is 3 in the double linked list. Now you want to insert number 44 between 35 and 54. That means after 35 you need to have a new node. Once you want to insert item in linked list, first you have to create a new node. So p new pointer new of type node, create a new node here. So this is how it looks like. New pointer points a new node, and then you need to take the target item into the data. So new data equals to item 44, and then you need to establish the link. Now you want to insert this after 35. You want to insert here, so that means 35 will link to 44, 44 will link to 54, and then 54 will link previous node 44, and 44 previous link will points to 35. Okay, so we need to establish the link of this new node. Okay, by having the current pointer and also all the pointer inside the node. So how are we going to point this new node to the 54? We need to establish here, because there's a link. The next pointer of 35 node here points to 54. That means we need to have a new pointer, new next points to the same link. with a current next. So current next points to 54 and new next also need to point to 54. So new next equals to current next. So new next equal to current next. That means whatever current next points at, the new next points at. Okay. Now we have established the link for the next. How about the previous? So we need to establish the new previous link point to 35. So what pointer that points to 35 is a current pointer. So current pointer points to 35. That means new previous equal to current. That means whatever current pointer points at, P new previous also points at. So we have established this link. Now it looks like we already established the new node link. Okay, how about the 54 and 35? How about this previous link also need to point to new node, and this 35 next node also need to point to the new node. Okay, so first we have to check the previous points to the new node. How you want to do this? By having P current next previous equal to P new. Okay? P current next previous point to P new. So whatever P new points at, P current next previous also points at. Okay? So if you move this away, it will make trouble. It will make quite difficult for assign this previous. So we need to do this previous first, and then now we can move the P current next equal to P new. P current next equal to P new. So do the previous first and then do the next. Now if you check the link, so 21 points to 35, 35 points to 44, 44 points to 54, and 54 points to null. Done. So backward, 54 points to 54, 44 points to 35, 35 points to 21, 21 points to null. Okay, good. So we already established all the link, and then what will be the next? We need to increase the number of items plus 1 equal to 4. So you can see that you already insert 44 after the 35 by using P current pointer and also P new pointer. Okay. Now this is the part of the code that we have done before. So you need to create a new node, new data item, and then you need to establish the link. The new next equal to P current next, and new previous equal to P current, and then you need to establish the link, the predecessor and the successor node, the previous node and the next node of the new node. Okay, and then you need to increase the number of items by 1. So how about you want to delete 35? First you need to point a current pointer point to the node that you are going to delete. You need to move your current pointer until the current pointer points to the node that you want to delete. So you have 3 nodes. Number of item is 3, and then current pointer points to 35. Now you want to delete this. That means you need to establish this node link to this 54, and this 54 node link to 21 node. So how are you going to do this? First you need to establish the previous or next link. Okay, now you see you have a next 54, previous, and then this next point to 54. Okay, now we move the next. So P current previous next, P current previous next equal to P current next. So whatever P current next points at, P current previous next also points at. So P current previous next takes the value of p current next. So that means p current previous next points to the whatever p current next points. Okay, and then we need to establish this previous. So p current next previous points at whatever p current previous points at. So this we need to do the link of 54 node, the previous link to the 21 node, right? So p current next previous equal to p current previous. So we already established the link. So p current next previous equal to p current previous. So whatever p current previous points at, p current next previous also point at. And then we can simply delete the 35. So we delete the p current. Delete the p current, and then we can know that 21 points at 54, 54 points to null, and then backward 54 points to 21, 21 points to null. Okay, so we already established the link, and we already delete the node, and then we decrease the item by 1, so the number of items equal to 2. So only 2 nodes available in the double linked list. Right, so this is the part of the code. Remember to establish the link, then you can delete. Establish the link first, then you can delete, and then don't forget to decrease the item. Now the next new topic will be the circular linked list. Why we need this circular linked list? It is use the same concept with single linked list, except that last node in the list that connected with the first node. So that means when you have a first node points to the second node points to the last node, and the last node instead of points to the null, it will point to the first node. So you can see that there will be a circular linked list. Okay, so therefore linked list will look like a circle round. Using circular linked list, searching process can be started from any nodes in the list. It will be much faster, much easier. Okay, so you can see that this is double circular linked list. You can go forward and you can go backward. Of course you need a head pointer. So different with single linked list, because searching process must begin from the first node. Double linked list and circular linked list are much better and powerful compared to single linked list, but the programming process is more complex because you need to move, and you can move from forward and backward. But if single list have to begin from the first node. So this is how you can represent the circular double linked list. You can draw like this with data, and previous next pointer will be at the bottom. So you can draw a square link to a second node, third node, fourth node, fifth node, and then this fifth node back to the first node. This is the head pointer. So data, previous, and next pointer. Or you can draw like this if you like. Then this node next point to the 5, 5 points to 4, 4 points to 3, and then 3 also points to 4, 4 points to 5. You can draw like this if you like. And then, or you can either like this, and node previous next, and then previous go to the next node, and next go to the next node, previous go to the previous node, and next go to the first node. Okay, so this is how you can represent instead of the normal diagram. It's up to you. Okay, that's it. Thank you. Bye.